Alright, here we are on the 5.3 homework. This is page 249. You can check these out. These are all proofs. And like I said, I think these are a little bit more manageable than the proofs we were doing before. We're just looking for evidence. We're trying to prove that this triangle is without a doubt congruent to this triangle. We need evidence. At the moment, they gave us some pieces of evidence. And if you remember, we can use side, side, side. So 3 sets of sides congruent would imply that the whole triangle is congruent. Side, angle, side, where the angle is included. You got angle, side, angle, where the side is included. And you've got angle, angle, side, where the side is not included. And then the last one is the HL if it's a right triangle. So those are the options. That's what we're trying to get to. We need to find 3 pieces of evidence, and then we're going to conclude that the triangle is congruent. Alright, so here we go. We'll start it off. And by the way, odds were 2-column proofs, and evens were paragraph proofs. So we're going to do 2-column proofs. Statement and reason. Alright, we'll start with our givens. The first given is that SPT, that's this angle right here, is bisected. So we'll start with stating that PQ bisects angle SPT. Now because of that, that means that this angle is congruent to that angle. I'm going to call it angle 1 and 2. Angle 1 is now congruent to angle 2 because of the definition of a bisector. Alright, so that represents a set of angles. That's an A. So more than likely we're not using side, side, side. We're going to use one of these. Alright, let's see what other evidence they got. We've got SP is congruent to TP. So we can put a little mark there, and we can put a mark there. Put that in the proof. That's another given. You can use givens whenever you want. And that represents a set of sides, so we got A and S. So still, we're using one of these 3. We don't have enough. We just have an A and an S. But over here in the diagram, we can see that both of these triangles share PQ, so we're going to write that PQ is congruent to PQ. That's called the reflexive property. And that represents a set of sides. And you can see that we got a side, an angle, and then a side. So the angle is included between 2 sides. That would be side, angle, side. So now we can make the conclusion. We have enough evidence now to make the conclusion that triangle SPQ is congruent to triangle TPQ by side, angle, side. Even though it's not in the right order in the proof, we've got a set of sides, we got a set of angles, we got a set of sides. We're good to go. Alright, on to number 16. This one needs to be a paragraph proof. So we'll start by stating our givens. AB is congruent to CD. That would be an S. And AB is parallel to CD. That is nothing. However, when you see parallel, usually that means look for a Z. So in this case, if these are parallel, this beautiful Z right here, that means that angle 1 is congruent to angle 2. So we'll finish our sentence. We can say, therefore, angle 1 is congruent to angle 2 because they are alternate interior angles, and the lines are parallel. And then again, AC is shared by the reflexive property. Therefore, that's the cheating way of writing therefore, so you don't have to write it all out. We can say that triangle ABC is congruent to triangle CDA. You always conclude with what you're trying to prove. And by, let's see what we got here. We've got a side, we've got a set of angles, and we've got a set of sides. We've got a set of sides, we've got a set of angles, we've got a set of sides. That's side, angle, side again. Alright, next problem, number 17. We are given that C is the midpoint of that and that. So that means that C is being a midpoint. This is the same as this, and this is the same as this. And we got the vertical angles, I'll call them angle 1 and angle 2, and that's going to be our proof. We're just going to state that we got these sides, and these angles congruent, and we're going to use side, angle, side again. So let me do that real quick. Statement, reason, C is a midpoint. Given. We can say that AC is congruent to CE, and BD is congruent, not BD, BC. BC is congruent to CD by the definition of a midpoint. We can say angle 1 is congruent to angle 2 by the vertical angle theorem. And now we can make our conclusion. This is a set of sides. This is a set of sides. That's a set of angles. The angle is between the two sides. So we're going to make our conclusion by side, angle, side. And we can definitively say that these triangles are congruent. They're exactly the same based off of that information. Alright, just a few more left, halfway through. And 14 is a paragraph proof. I'm going to cheat. I'm just going to take all of this and ... as given. Alright, so what do we have so far? We have that G is the midpoint of E and H, so I'm going to highlight that. G is the midpoint of E and H. We have that FG is congruent to GI, so that makes this also congruent to that. That's what we have. And we have right angles. Now, because these are right angles, that makes this a right triangle, which makes this a hypotenuse of this one. It makes this a hypotenuse of this one. It makes this a leg, and it makes this a leg. So I think we're ready to make this conclusion. We can just say, therefore, triangle EFG is congruent to triangle HIG by the hypotenuse leg theorem. That's really all there is to it. They gave us every piece of information we needed. To use the HL theorem to make triangles congruent, you just need a hypotenuse and a leg. That was pretty straightforward. On the next one, they have given us that LM is congruent to JK. That's an S. That's a set of sides. We have that MJ is congruent to KL. That's a set of sides. And look at this, they share the middle piece. That's our third S. That's going to be an S, side, side, side one. So you write out your proof. You need to have 3 pieces of information. LM is congruent to JK. MJ is congruent to KL. That's given. JL is congruent to itself. That's always the reflexive property. And that is all we need. This is an S, that's an S, that's an S. We can conclude what we're trying to conclude. LMJ is congruent to JKL by side, side, side. And last problem. Alright, sometimes it is appropriate to look at the triangle you're working with. You're working with this triangle right here. So I'm actually just gonna separate that out. It's not perfect, but it does the trick. And then we've got this triangle here. I'm gonna separate that one out. That is triangle VWX. Alright, it's odd, so we'll do a 2-column proof, statements, and reasons. They give us quite a bit of info just starting off there. Is this triangle the same as this triangle? That's the question. Alright, so statements. VW is congruent to UW. Given. And go ahead and put this as well. There's our given. So let's label that on our picture. VW is the same as UW. That's an S. That's a set of sides. So we have an S. Do we have more? We have that angle X. It's congruent to angle Z. That's an A. That's a set of angles. Is that enough? Can we definitively say that this triangle is exactly the same as this triangle based off a side and an angle? And the answer is no. You need one more piece of information, and that is, look at this. They both have angle W.